You have to get us out of here now.
Select landing target.
There it is. Hurry up, we don't have much time.
Landing target located. Attention. Multiple weapon signatures detected. Incoming.
Baker. They're here.
Shield taking damage. Warning. Power down to 32%. Substantial damage to shield. Power down to 17%. Core energy depleted. Shield power down to 9%.
I'm sorry, Vader. Sorry.
Warning. Shield has been deactivated. Immediate evacuation. Proceed to the tenders now.
This is a quick session. I say quick, I think we're going to kind of take about an hour here, so we're really going to go through, take it at a nice pace. I'll say at this point, if you want to follow along and kind of do some stuff while I'm doing it inside the editor, then if you get any kind of version of a Unity project open that's in HDRP and has the visual effect graph package installed, get that project set up, and by the time we get to the demonstration, you might be able to follow along, although I will be going maybe a little bit quicker than a kind of exact tutorial. Okay, so yeah, this is getting started with the visual effect graph. So we're going to go through the advantages of the visual effect graph, getting started with it, and then kind of creating an optimized weather visual effect. So my name's John O'Reilly. Some of you guys might know from Twitter. I used to be an evangelist at Unity, teaching people how to use all of these tools. And as you can probably tell from the backgrounds, I am reusing, and I've just slightly updated a talk that I used to give while I was working for Unity. But now I work as a freelance tech artist, working in kind of real-time animation, augmented reality, and all that good fun stuff. So I will go through at a pretty safe, comfortable pace, but if you're like the sort of person that wants to come back to the same information later, basically everything I'll explain here, the basics about using it, are also explained in this blog post I wrote called Creating Explosive Visuals with the Visual Effect Graph. You can find that on the Unity blog. Just Google the title, you'll find it there. It's also my portfolio if you want to find it there either. So the advantage of the visual effect graph. So compared to the particle system, the visual effect graph has many, many advantages, but there are also a few kind of limitations compared to the particle system. So I'm assuming everyone here has at one point experimented using a particle system. Sorry, can we get everyone to mute themselves? There's a lot of background noise from someone. So with this particle system, you had to edit everything in this kind of inspector view on the right in Unity. All tiny text, enabling and disabling modules is hard. If you want to control the exact position of a particle I found recently, then you have to really kind of combine the velocity with the different forces elsewhere and a little bit of noise, and it all quite gets out of hand. You have kind of very limited control over what you can do with the particles at any one time. And that you can only have thousands of them compared to like the millions and millions that we're seeing with the visual effect graph. But as we compare the two, we can see that we can have much more particles. The simulations we can do are much more complex. We can handle throwing much more data at it and layering that data to make it move in specific ways. When it comes to actually doing physics, so whether or not it collides with something, because the visual effect graph is running on the GPU, not the CPU, where physics is calculated, then you can't actually read back when a particle is colliding with something like you can with a particle system. But you can get around this by baking out certain types of data. So you can use the depth buffer from the camera to position particles, and you can use very basic primitives like feeding in a box or a sphere. And you can also do scene representation by baking out what's known as a signed distance field or SDF file. Read back from gameplay, you can't do. So again, because this gameplay has been calculated on the CPU, you could bring over a small amount of data potentially, but it's much better to kind of work out what you want the visual effect graph to be representing and then feed that data into the visual effect. And you also have the benefit of reading frame buffers, much like the depth buffer or color pass. which is super handy for a lot of effects. So getting started. Visual Effect Graph works with Unity 2018.3 and up, so I'm assuming most of you guys are working in non-production projects right now, and even if you are working in production, I would have hoped that you've upgraded to 2019 at this point, in which case Visual Effect Graph works. It works with both a universal render pipeline and HDRP. If you're still working in a lightweight render pipeline project, there will be some limited support, and for the built-in, there is also very limited support, but I wouldn't recommend it. So you really want to be creating a HDRP project, especially if you're doing this kind of portfolio work or just to mess around with it. So create that project with HDRP and the Visual Effect Graph package will already be installed. If it isn't installed or you've already got a HDRP project already, and you've manually added HDRP, then you can go into the package manager under Window. You might need to show preview packages if you're in an older version of Unity, but nowadays probably not. Find the Visual Effects Graph and then click Install. So some quick terminology. We have nodes. You might be familiar with Shader Graph's node editor. We have contexts, which is each stage of what's happening. And then we have blocks, which are adding functionality to the graphs here. So the entire thing, all of the contexts added together is called a system. So each context contains blocks, and then you calculate something with nodes and then input that into the block to add it to the visual effect. So the first block here, we've got spawn. So spawn says when the particle system starts, how many particles are spawned. Is it a burst or is it a continuous flow of particles? We then have the starting values. So how many of the particles can exist at once? So the capacity, we need to set that out before we go any further. Then where they're spawned. So is it spawning inside a box or from a single point? Do they have velocity and how long do they live for? So they're starting values. Then we have update, which changes their behavior over time. So once they're spawned, are we changing their size? Are we changing their movement? Do we change their color? So a lot of kind of the extra functionality is probably going to be placed into update, but it can also be plugged into output. So the output is mainly about rendering the particles. So what type of particle is being spawned? Is it a quad output? Is it a mesh that you're spawning? Is it a sphere? Yada, yada. And which direction does it face? As well as kind of which texture is it using? Which shader is it using? This is a slightly older screenshot, but the Visual Effect Graph now works with Shader Graph. So if you wanted to make a Shader Graph asset to work with it, you can do that, and then select that as your shader. And yeah, you can also select a kind of set of pre-made shaders, your usual opaque shaders, lit shaders, unlit, additive, masked, all that good stuff. It's worth remembering which of these shaders is more expensive to render. For example, additive is nice and cheap, and something like alpha blended is maybe a little bit more expensive. So it's worth knowing that. So let's get into the demo. Let me just switch over to Unity here. Cool. So this is actually an older project. What we're going to do is we're going to create an entirely new test scene. Let's go scene. There we go. Okay. Oh my God, my computer is really not happy with me. I'm currently running on a laptop, and I currently have a fan pointed at my laptop because it is rather hot here in the UK, and my flat is a microwave. Okay, so you can see I've shifted around the kind of Unity layout a little bit here, and I have my project view down here at the bottom left. Now, previously, in your hierarchy is where you would have created a particle system, right? If you've gone through that process before, you go to Effects, Particle System, you create it in the hierarchy, and then if you want to reuse that later, you have to store it as a prefab, which isn't the best workflow. So what I'm going to do here in my Assets folder is right-click, go to Create, go to Visual Effects, and create a Visual Effect Graph. We also have the options here to create an operator, which is like a kind of subgraph, if you're familiar with Shader Graph. And then we also have Block, if you want to add your own custom functionality. But for now, we're just going to create a Visual Effect Graph and name it something I can remember. Cool. I'm actually going to maybe shut down PowerPoint here. I don't think PowerPoint has a huge overhead, but I will just shut it down anyway, just so we can get the most out of my computer right now. I'm just going to shut down Chrome just in case. Okay, so now we've created our Visual Effect Graph asset. I can now pull this into, okay, my computer is a little bit slow. So now I pull this into the scene. And we can see here that we have a very basic visual effect happening, quite similar to the one that you would have created if you'd created a particle system. If I want to edit that visual effect, then I just need to double click on the source asset. Why is my computer frozen? I'm actually going to, unfortunately, close down my my crazy webcam effect and just quickly switch that over to, let's go for this one. Okay, cool. Now I'm not running a visual effect at the same time. That's a little easier. Okay, so let me double click on the visual effect here and we'll load it up into the graph. So first of all, our blackboard's in the way. So our blackboard is where we store properties later on if we want to modify them with a script or modify them in the inspector. Right now, I'm going to turn this off with a button at the top right here that says blackboard. And we can see that we have the kind of top to bottom flow that's pretty familiar, or pretty similar to the one that you would see in the inspector with the particle system. So again, at the top here, we have the constant spawn rate. So let me just drag this over. To move around the graph, I click middle mouse button and kind of zoom in and out, scroll the middle mouse button. And if I want to add and change blocks, I will press space. So right here, I've got a constant spawn rate, but I could also change this to a periodic burst. And we can see here, if I disable this block by unticking it, and then set count to 20, and then put 0.2, actually let's put 1 second here, we can see that automatically it's recompiling to, actually let's hit compile here. Is that working? There we go, we can see we've got now a burst of particles coming out each time. I'm just going to put this back onto the constant spawn rate. And I'm just going to hit the delete button. You can also right click to delete to remove blocks. So let's go creating a snow weather effect first of all. So I'm actually, before we do that, let's just quickly go down the graph. So we've got our capacity. Because we're calculating all of the particles on the GPU, to actually detect where all of the particles are in the camera view isn't really possible. So in order to tell Unity whether or not we should be rendering this visual effect or even calculating it, we want to give it all of the information before we start rendering it. So the capacity is actually telling Unity how much memory to allocate on the GPU. So don't set this too ridiculously high. You can kind of calculate how many particles you'll be having if you take a bit of time to take their lifetime and how frequently you're spawning them. But for now, I'm just going to jack this up to 2 million because why not? Cool. So we also have the bounds, and the bounds tells Unity whether or not to be rendering it, whether or not really if Unity is looking at it. So if I select my visual effect here, you can see here in the scene view that I have some controls that have popped up. So I have here the play controls, which will allow me to control the playback of the effect, so I can pause it. I can also slow it down, so if I change the rate to 4 here, you can see that, maybe a bit too slow, you can see that it really starts to crawl along. This is really useful if you're creating a very nice layered visual effect, where, like an explosion, for example, a lot of things need to happen at once. And if you really want to make sure that perhaps the thing that moves across the floor and the things that get flung into the air kind of happen at the same time, you can slow it down and actually check what's happening. We can also set up events here. So if it's not a constant kind of effect that's playing, perhaps it's a gunshot that needs to be triggered, you would connect something to start here and trigger that with a script. But if you don't want to trigger that with a script, you can also play and stop it here. So we also have the event tester. Events are something that you could feed in through scripts to trigger these effects. And we also have show bounds, which I'll tick here. So you can see if I kind of move my camera, actually maybe it's all within the bounds. So actually if I jack up the kind of velocity on the X and Z axis, we can see here that the moment, select that, the moment I move my camera outside of those bounds, it stops rendering those particles because Unity is now culling the visual effect. So if your visual effect is disappearing, that's what you need to change. You need to kind of unfold the little bounds thing here and then make sure that this encapsulates the entire area of your visual effect. Okay, so I want to make snow. So the rest of this is pretty straightforward. Size over lifetime gets larger. Set color over lifetime. We have the alpha being controlled here as well as the color. So it goes from completely transparent to opaque. And then we also have it orientating the face camera plane. So you would replace that block if you didn't want it to face the camera plane and instead have its own orientation. And we also have the main texture here. We're going to leave that on there so we can see a little bit easier where the particles are for now. But let's make some snow. So first of all, I want to be spawning this in a nice big box. So instead of kind of having nothing here to set the position, I'm going to press space and I'm going to search for position AA box. And the AA part just stands for axis aligned. So it's basically just a box. Let me just move these all out here. Okay, and then we also have the ability, we can see here that's kind of spawning on the surface. If I go to volume, it will now spawn them inside of this box, but we actually can't see the box. So let's make something that we can edit. So I'm going to bring my blackboard back up here, and I'm going to hit plus, and then I'm going to go down to axis aligned box, which is here. I'm just going to leave that as the default name, but actually let's double click it and let's call it our box. Why not? Or the best box. Cool. And I'm going to tick exposed here, so we'll be able to see it in the inspector. And then I'm just going to give it its default parameters of 10 by 10 by 10. We can also give it a toolbox. It's the best. So if you're handing this visual effect off to other people later on, and you want them to know what's happening, put a little tooltip in there, and it can explain to them. Okay, so now we've got our box parameter. I just dragged this in. You can drag in the same parameter multiple times if you want it to be referenced in multiple areas. I can then pull this and connect it to the bounds of the box here. So now when we're computing the visual effect, it will always be within those bounds. And if I select the kind of node here and pull it into position AA box, they're now both the same thing. So if I select the visual effect in our scene here, we can now see we've got this huge box where all the particles are spawning within. So let's actually up the amount of particles that are being spawned to 200. And I'm just going to untick set velocity random here so they all stay still. So we can see here they're all being spawned within this volume. If I change this back to surface, you can also give it a thickness if you want it to kind of be perhaps on the outside of a sphere. You can do that too. So you can see here there's actually no particles on the inside. I'm going to take this opportunity to also show that there are ways to modify these blocks in the inspector. So if I click on position AA box here, we have the ability to change its parameters in the inspector. Because I also have show debug information ticked to my preferences, I can also kind of see what the shader is doing as well, which is really handy if you're a lot more technical than me and you like reading numbers instead of going through all the notes. So let's change this back to volume for now. This is also really handy if you want to maybe customize a block that isn't actually in the list when you search here. Okay, cool. So if we're making snow, I probably want them to live for quite a long time. So I'm going to set this to perhaps 6 to 8 seconds for the lifetime of our snow. I'm going to re-enable the set velocity random. And what I'm actually going to do is just make sure that they all float downwards. So if I set this to -5 on the y-axis, and then set this to -0. Actually, let's put -1. And if I hit compile, I'll just refresh the entire visual effect, and we can see all our particles are now spawning and kind of going downwards. So I'm going to set these on this here so they kind of move not directly downwards, but they all, some of them move slightly on the x-axis, some of them move slightly on the z-axis. Cool. And now we basically have all of our particles. I'm going to go in here and also we've got set size over life. I'm just going to disable that for now. And you can see it's already a lot smaller. If I go into set size, probably the last thing we want to do an initialize particle. And cool, we have a bunch of nice little small little planes flying around. Cool. So now we might want to add some turbulence to the particles. So in update particle, I'm just going to press space and I'm going to search for turbulence. And turbulence is basically just 3D noise here. It's kind of pushing them around in random directions. And you can see that I have a bunch of ways to modify. Just close the blackboard. We have a bunch of ways to modify the intensity of it, the drag of it, and all that. So if I move this up, you can see the particles get flown everywhere. I'm just going to leave that on, yeah, maybe increase the frequency here. So they move kind of, they shake a little bit more than kind of nice sweeping moments. And I can actually, yeah, let's actually make it a little more stronger on the y-axis here, because right now some of them are getting flown up. Of course, depending on the type of slow, some particles might kind of get lifted by the wind. But yeah, we can see we've got a bunch of particles flying around. This looks too strong to me. Let me move the intensity down. Some of them are still flying up. And I'm just going to hit compile. So there we go. Again, that's looking more like snow. Okay, cool. So we have set size over life. And if I disable set color over life, they'll just appear. And then they'll also snap out of existence as well. So what I'm going to do is I'm actually going to tick set size over life. And in the inspector here, we currently have overwrite. So if I open up this kind of animation curve here, we're seeing that it's setting the particles to start at 0.1 and then going all the way to 0.5. I'm going to replace this with a little curve I have that takes it all the way from 0, moves it up to a maximum scale, and then moves it down again. And then in the inspector, in composition, I'm going to change this instead to overwrite, so instead of replacing the values, to multiply. So now we can multiply things by 0, complete disappearing, to 1, whatever our scale was before. And I'm actually going to leave set color over life off, but I'm actually just going to replace this with a set color node, because I don't want it necessarily fading in and out. I kind of want it to kind of almost look like it's shrinking out of existence. Cool. And finally, I'm going to take the default particle here and actually replace it with the other default particle texture and change the alpha blending mode. So I've got blend mode here to additive. Cool. That's starting to look a lot more like snow. So since it's a kind of a small group, that's the kind of basics of how I'd start going through a visual effect. In a second, we're going to change it to rain, but does anyone have any kind of questions at this stage?
Not so far, no.
Not so far.
Okay, cool.
Yeah.
It's all. I'm keeping it nice and easy because
I'm just compiling it. Yeah, it's okay.
Okay, good,
Yeah.
good. Cool. So what I'm actually going to do here is something I haven't done for a while, but we'll see how it goes. This turbulence isn't really giving me the force that I wanted, so I'm actually going to quickly try adding to its position. So if I press space and I go to add position, and just add that there. Cool. So it's going to take its existing position and add to it. So if I create an animation curve like this, oh, I accidentally unfolded that. If I drag this out, and you can see here that it's contextual. So there's only one thing that this animation curve can do, and well, maybe there's a few things, but I want to sample it, right? So by dragging that out, I can find the nodes that are compatible with that one. So it's really nice for discoverability. By the way, a lot of the nodes are documented online, but for me personally, once you kind of get a kind of understanding of what kind of nodes do as a functionality, it's just a case of, are you adding it? Are you multiplying it? Is it about their position? Is it about their velocity? Yada, yada. Okay, so we have a sample curve here. And if I actually replace this with a really shaky one, and then let's take a vector 3. So let's go to create node. Vector 3, actually, yeah. Because I used to do this part of the demo over a year ago, so I'm trying to think what the hell the setup was. Cool. So actually, if we're adding to its position, let's add to it only on, say, the x-axis. So if I hit this tiny arrow here, we can unfold the add position graph. And then if I drag this into x, right-click, I'm going to create a time. So you can see there's multiple different types of time. So you have age over lifetime, which is a value that increases from 0 to 1 over the total lifetime of the particle. But I can also get total time, which is kind of like the world time. So that's similar to time in shader graph if you used that before. So now, why is this not working? Where have all the particles gone? Let's hit compile. That's strange. Okay. Let me disconnect that and confirm that's what's breaking it. Whatever. I'm actually going to move on from this part. I thoroughly embarrassed myself, but instead we're going to demonstrate another feature. So instead, in update, I'm going to retake turbulence, leave that on for now. If I go into here and create a tile warp positions node. So there's some really nice blocks that you might not necessarily know are there, and tile warp positions is one of them. And what it basically does is it contains, as you can see here, all of the particles within a block. if a particle moves off one side of the box, so if it moves off the bottom, for example, just like the video game Asteroids, where if you flew off one side of the screen, it would come up from the other side, it does exactly the same thing. So if I actually take the bounding box that we created earlier and put that into tile warp positions, and then actually let's make this box smaller. So if I select the visual effect here, you can see that there's gizmos here at the bottom of play controls. If I get that drop down, it will find any of the properties which have gizmos attached to them. And here I can actually rescale the visual effect inside of the editor. So I can pull this box and kind of make it as large as I want. Cool. So maybe this is a bit small to see. Actually, oh, one last thing I need to change. This isn't immediately apparent, but this tiny thing here that says local is actually a button. So if you click that, it will change it to world. So now all of the particles, if I move this box around, will stay in the right position. And we can see here, even though the particles aren't here when I initially move it, as this part of the box gets moved over, they'll all snap to be inside of the box. So why would you want to do something like this? Well, for a snow visual effect, you want to give the illusion that the entire scene is covered in snow, right? But you don't necessarily want to be, you might have a really large scene where, you know, that's like thousands of meters of area that you'd be calculating particles from, maybe not necessarily when people are even looking at them. So what you can do is I can take my main camera here, and if I take this visual effect and kind of move it onto it, and then if I nest the visual effect in the hierarchy to the camera, now we move the main camera as well, the visual effect will move with it. So if I change to the game view here, and then, oh, let's actually pop these side by side. Game view, ooh, put the game view there. Cool. We can now see that as I move this, I mean, it's currently a little maybe small for the camera. You can kind of see them clipping in. Let's actually just shift that over slightly, and let's just increase the size of the box here to something that's a little bit bigger. Oh, that's too low. 100 is probably too big. So that's a 40. Again, probably too big. I think the camera frustum is probably just too wide. 2 seconds. Let's set that larger as well. Cool. Okay. And I'll just restart the visual effect here. So now we've got all of the particles within this, and as we move the main camera, the particles will stay in position and fly past, but they'll pop into existence just at the edge of it. Now, say you've got particles flying into where the camera is. You go down to output here, and if I go into, if I just go for fade, yeah, camera fade, that's the one we want. So we have, we're now setting up an effect where, based upon how far away the particle is from the camera, it will fade it. So we have the visible distance here is 2. We could lower that, but we should be able to see, maybe not, the particles are quite small, but particles should fade out as they get closer to the camera. Maybe it's not that apparent to see. Okay, let's move on. So let's create a rain visual effect. So we have all of our, I'm actually just going to unbound this, and I'm going to very quickly create a 3D plane. Cool. Let's go into the directional light and change it from something that isn't gross and yellow. Oh, cool, it's already white. We're winning. Okay, and let's change this plane to be something that isn't completely white so you can see on it. So I'm just going to create a quick material and then drag that onto the plane. Maybe the light is very bright. It could be the case. Maybe I should just reduce the intensity of the light here. That's actually cool. And let's set this to be something that isn't exactly white. Let's set this to be gray. It's very bright still. And I guess it's
the
light.
intensity is too high actually.
See, this is the default. I lowered it, didn't I, to like, okay, maybe it was just mad too high. Oh, I think it's because in change of color temperature. I think it's because in HDRP you're actually supposed to have realistic light, which is really, really bright, and then with your post-processing you're supposed to reduce the exposure of everything.
Yeah.
But I guess I might not have it enabled here. Whatever. Cool. We've got our plane back in, and this light is perhaps still too bright. Cool. Okay. So let's get our visual effect back onto the camera. Oh, actually, let's move it. Let's center everything in the scene. Cool. Okay. Alrighty. So now we want to go back into our velocity here, and I'm going to say that the rain is going to mostly be moving straight down. So I'm just going to give it a tiny amount of variation on each axis here, but otherwise we want it to be moving like this. Cool. And let's set the velocity to be kind of consistently like -5, because rain usually kind of moves at almost exactly the same speed. Cool. That's still rather slow, isn't it? I think it might be because I've got turbulence here, which is also interacting with it. So we're going to take that out. Okay, cool. So now we have maybe a little slow, but it is rain. It's particles that are moving down. I won't make it too much faster just because it would then be hard to see what's going on. And I'm actually going to make this a little bit bigger and also set the color to pink so that we can very easily see where the particles are. Cool. I'm also going to change this default particle very quickly to something which is nice and blocky. Okay. And actually, if I go back into the set size here, I think I can do set size. Or is it set scale?
7.
Set scale. Cool. So with set scale, I can now set this to be kind of much thinner. There we go. If I hit compile, it should refresh all of it. And we can see actually, because it's over time, it comes in a bit slower. So a nice trick is if you want something that's kind of a persistent effect, as in it's supposed to be there when the scene starts, if you go to single burst, and then if you set whatever your initial kind of spawn would be, then immediately as you start the effect, there will immediately be 200 particles there. Cool. Okay, so I want to set this up so that when the particles collide with this floor here, it makes a little kind of splash. So let's go through that. So something I quickly forgot to mention is that from top to bottom, if this isn't already apparent, this is the order of operation. So if you're setting something at the top and then resetting it later, that would be considered overwriting it. So it goes top to bottom and kind of goes through in that logic there. Okay, just realized we can also make this, instead of magenta, we can also make this maybe look blue, which is just as visible and maybe more rain-like. Okay, so how do we create a kind of little splash? So you might remember that we can't check collision, but something we can do is we can read the buffer. So the buffer we're going to read is the depth buffer. So for people not familiar with the depth buffer, is there actually a debug mode for it now? No, that's a shame. Let me quickly get an example. So when you're rendering stuff, one of the kind of things that we check is how far away is each pixel from the camera, and that gives us the depth buffer. So it will be this black-white texture, sometimes inverted, where white is closer, and usually it's kind of darker where it's closer, because it's closer, so it's not as far as away, so value is smaller. But we can use this texture being given to us by the camera to detect collision as well. So to do that, what I'm going to do is in update particle, I'm actually going to kill, actually wait, hang on, GPU event. So if I go to trigger GPU event on die, and if I actually go to, if I go in here and go into collide with depth buffer in update particle, cool. And then I can say that when it collides with something, it loses its lifetime. So we can see underneath, ooh, actually, this might not work because it actually takes the depth buffer from this camera here. So let me, quick hotkey. This is also under game object aligned with you, but control shift, oh, I turned off my video accidentally. There we go. So if I select the camera, and then wherever my scene view is pointing, control shift F, and I'm now going to move the camera to whatever I'm looking at. So we're actually getting the depth buffer from that camera there. Cool. So you can see here, potentially, let me move that camera a little bit out. If I move this out here, cool. So we should be able to see that no particles are actually falling through this plane here because they're colliding with it and then being killed. And we also have this event here, which is then being triggered when they die. So we can also actually set things like bounce. So if I reduce the lifetime loss and keep the bounce on 1, you can see they're colliding with the plane and then bouncing up. But we don't want to do that. We want to trigger a different visual effect. So if you want to create entirely new systems, one of the lovely things about the visual effect graph is that instead of combining multiple particle systems like before, you can have one visual effect asset or one visual effect template, which is then pulled into the scene. And inside that visual effect template, you can have multiple visual effects. So say for example, you have a giant explosion and then you want fire afterwards. You can actually have all of that inside one asset, which is really handy. So in order to create a new system, I can right click, go to create node, and then you'll see here there's also the system presets. So I can create a simple particle system. So much like the one we started with. There's also a more complex one, so I'll quickly show off the swarm particle system. It shows using turbulence, sorting on the sphere, the surface of the sphere, and obviously much more particles. But we don't want that one for now. It's far too much. We just want this effect here. So we can actually get rid of spawn here, or can we? Yes, we can. And I can search for GPU events and then drag this in. So with the down here, so let's actually pull this all the way down. So trigger event on die, let's put it down further. So when this particle dies, I want it to trigger this visual effect. So we'll already see this happening, especially if I uncap the capacity here to something much higher. You'll see that because so many particles are colliding with it, it's constantly spawning and triggering this visual effect. So this little number here determines how many particles are going to be spawned. So I'm actually going to set this to 8. And then I'm actually going to very quickly go through and repeat a lot of the same stuff we did before. So I'm going to, instead of add size. So actually, let's say I did add size there by accident, or I'm coming back later and I want to change that. In the inspector here, I can go from add and I can simply change that to overwrite, and now it'll be set size. Cool. I'm going to go back to set size over life and repeat that so that it gets kind of larger and smaller. And because it's an impact, I'm actually going to delete this one here. You can see that's flattened out so that when the particles spawn, they'll be their maximum size. And again, this is set, so I'm going to go here and change that to overwrite. Sorry, multiply. You can see here we've also got, if we wanted to change things like the texture index, the age, if we wanted to change what property it's changing, we can also do that in the inspector. Cool, so now we are spawning tons of tiny particles, but they're not in the right position. The velocity also seems to be perhaps a bit much, but instead of going through all these numbers again, I'm actually going to search for multiply velocity. We've got multiply angular velocity, so multi-velocity, yeah, there we go, multiply velocity. And we see here we've actually got a vector 3, so I'm actually just going to go in, search for float, and I'm going to uncollapse this. Actually, no, I don't think I even need to uncollapse it. When it gets plugged into this top one, it should kind of go through all these other vectors as well. So if I set it to 0.1, yeah, you can see there it's all being set to 0.1. So now we have tiny, 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 tiny particles spawning. Let's set this to 0.5. Actually, we're not changing the size, are we? We're changing the velocity. Cool, so now they're not going as far. Set to 0.2. Okay, but now they're not in the right position. So if I go into initialize particle, part of what we want to do is we want to inherit the source position. So if I put inherit position, boom, and kind of can be wherever, but you can see here now where particles are hitting. We're now spawning this tiny splish splash. Let's quickly go through and change this into a nice kind of little dot. Actually, that we're going to want to reduce overdraw, so let's make it this one here. Cool. And let's go back into set size and let's make that a tiny bit smaller. Okay, cool. So now where the rain is hitting, we have these tiny splashes going on. But they're kind of floaty and stuff. We want them to kind of be more of an explosion. So what have we got here? let's actually add some gravity. So if I go into update particle, search for gravity as a force, we'll now see that it's adding quite a lot of gravity. This is the realistic amount of gravity. So what I need to do here is I actually need to up the velocity. So you can change things like mass. For now, I'm just going to fiddle around with these numbers. You can do your usual stuff of doing the maths inside of each thing. So if I wanted to divide this by 2, I could hit /2. Cool. And then, you know, these are living for quite a long time. Let me just reduce that to 1 so they kind of splash and multiply size over lifetime. Let's take off the fade and let's reduce their lifetime to, let's say, 0.6 to 0.8. Cool. So that is the basics of kind of creating a rain effect here. So you'll see that as I fly around the scene here, it should work okay because this camera is rendering the depth buffer. But if it doesn't quite look right to you in the scene view, that's why. But yeah, and because this isn't actually using colliders, so if I actually turn off the mesh collider here, it will continue to work. And I could also add multiple meshes which either have animations on them, they're skinned meshes, they don't have colliders on them. So let me actually go in here and take, what else have we got? Let me search for Hatchie. And let's pull in, trot, bear with, let's just search for FBX. Mesh, that should get us somewhere. Okay, I can't seem to find any good tests. Oh, here we go. That's a nice test asset. Okay, cool. So is this within the game view? Let's see. Actually, let's increase the amount of rain dramatically so that we can see it colliding. So let's go over here to where we're spawning them, and I'm just going to jack this up to 20,000. Cool. So we now have tons and tons of particles, and we should be able to see with this here, yeah, that they're also colliding with the surface despite this having no colliders because it's using the depth buffer. So in a way, it's a really nice workflow if you want particles going to be bouncing off and colliding with things. You can play an animation back on this, and that would work as well. Cool. What else is there left to show? Okay, so that's the basics of kind of using it. I'm afraid I haven't done any complicated node stuff this time because I'm deathly afraid of getting some of it wrong. But I will quickly show some very quick things with the nodes. So say I wanted to create let's say we wanted to multiply stuff, right? If you use shader graph, you'd be familiar with the whole thing where it's like, oh, I want to multiply these kind of 4 things together, right? Like you want to multiply, like say 4 floats, or like a float and a texture or whatever, and you have to do this whole setup where like, this one plugs into this one, and then this one plugs into. It's gnarly. It's stupid, right? What you can actually do here is just drag it in, and you can have as many of these as you like, and it will just keep expanding. Say you don't even want to create these to begin with. Say you want to multiply multiple things together. This tiny setting gear here, if you tick that, you can actually change what it's expecting as an input or what you're generating as an input. And you can also add more of them. So instead of adding all of those nodes in, you can go in and you can say, oh, I want this float to be, changed by a vector 4, which is also somehow being, controlled by a this or a that. You get the idea, right? That's also really handy if, you want to perhaps lerp between 2 things. If you go to the drop down here, you can change that so that one of them is expecting a color and another one is expecting. Can you actually change? I think it changes both of them. It does change both of them. Cool. You see what I mean, though. So you can also tell by, just like shader graph, what kind of data it's expecting by the color of the output. So here it's outputting a vector 4. So all of the things that will accept a vector 4 can be put into there. If you want to load in a shader graph, if you go onto the output here, you can see at the top you've got shader graph, and it does need to be a specific type of shader graph. So if I go into my assets here, and if I just right click, go to create, go to shader, and then go to VFX shader graph, it's a lot more basic, as I'll show now, because it only has the output for color and alpha. But if you wanted to pan some textures or something, maybe create a little bit of extra logic, you could do that as well. A lot of what you'll be doing is sampling the particle's position. So let's actually quickly demonstrate that now. So here I've got set color. If I actually change this to let's say, yeah, let's do this. I'm going to do a comparison. So I'm going to say so let's get the particle's position. So gets position. So this is going to be the current position of the particle, and source would be from the last particle system you're hooking it up to. If I unfold this, I can get the particle position on the y-axis, and I can say if this is less or equal to, just leave it as less. If this is less than 0 on, say, world. Wait, how am I doing this? I need to get the world position, or can I? No, it's already the world position. If it's less than 0, I can then use this statement for a branch. So we can see here there's logic, branch, cool. So if this is true, if it's less than 0, then I want to set it to be, let's say, different color. So let's bring in a color. Let's say if it's less than that, we want to set it to be pink. And otherwise, we want it to be its usual blue. So we go in and change that to blue. Cool. And then plug that into the set color. Haha, that hasn't worked. Why? What are we doing here? See, this is why I didn't dare live do node stuff. I should have actually double checked how I'd done this before. Actually, what am I doing? I can just load up that visual effect. So the visual effect graph window will remain persistent. So if I open up this window here, I think it says there's nodes from the last time I tried to do this demo, and I floundered. Cool, okay, we're actually using a branch, which is then lerping it. Interesting, okay. So if you want to reuse nodes between stuff, you can just select all of them, hit copy, and if I go back into my other visual effects, cool. And what time are we on? Okay, we're nearly up to the hour, so I'll start wrapping up. Cool, so let's get rid of all these nasty nodes I had before. Cool, and let's paste in this one. So you can see here, these are all a group. The way you group assets is you go, well, let me just delete it and redo it. Select all of them, right-click, and you'll see, you right-click on one of the nodes, and you'll see group selection, and then you can give it a name. Cool. So now if I drag this into, this actually seems to, yeah, let's just set the color. Is this going to work? Hey, there we go. So we're doing the same thing. I just got this little lerp bit here. And we can see that as the particles go past 0 in the world position, I'm now overriding their color. So I'm going to barrel through a bunch of stuff really quickly. A bunch of extra quick tips and stuff. Okay, so this is going to be light speed. So we've got the group of nodes here. What if you wanted to do things like annotate stuff? If you go to right-click, create sticky notes, you can create notes and you can put in, how things are explained there. If you want to kind of annotate entire systems, each thing can be titled. So I'm going to call this rain, and then this will title the entire visual effect here. If you want to title each section, you can, this kind of box here, which is tightly hidden, if you double click that, you can title that as well. As you go through all the VFX samples, you'll be able to do that. You'll be able to see that there are notes everywhere of how things are being explained. Once you create a sticky note, you can also change the scale of it, and you just right-click it, change how big the text is. You can also rescale it like that. You can have multiple visual effects in the same thing, and you can also use it to trigger things. So the spawn event here, I could actually use to trigger a different visual effect. I'm not going to go through and show all of this now. So, I don't know what I created there accidentally. Yeah, okay, cool. So whatever this visual effect is here, say I wanted this one to be triggered after this visual effect. I could actually take this spawn event and then plug it into start. And then when this visual effect starts or stops, it would then trigger this other visual effect. I could also have it so that one is triggered and the other one stops just by hooking up all these nodes. Say you're doing this for an actual game and you want to feed events in, you just type event and use this to either start the visual effect here or stop it. So give it a name and trigger that with code, start the visual effect. Events could also have things like the position of where you want to trigger them. So if you want a gunshot and you're doing a ray cast to see who it hits and where a blood explosion should happen, you can feed the initial position and its target position in through the event and trigger those as well. Sorry, there's so many things to go through. I will quickly list more of these things off. So we've also got, if I go into preferences here and go into visual effects, that's the last thing. There's experimental operator / box. This is previously where GPU events were hidden. I'm not sure what is contained as experimental right now, but if you tick that, you can also have show additional debug information. If you tick that, when you're selecting things here, it will give you this data as well. There's also some extra settings if you want to play around with those. In the actual visual effect asset itself, you can uncollapse it and you can see the surface shaders that are being rendered for the actual surface of the particles. And then these here, the CS, that is the compute shaders, which are actually managing the positions and spawning of all of the particles. So if you wanted to go through and you know how to use compute shaders, you can actually go through and break those down as well. Wow, okay, this is really stressful to look at, all of this rain. Let's knock a 0 off that very quickly. Cool. So what else have we got going on? There is the binders. So what I can do is, we're setting all the color here. I'm actually very quickly going to set this up to alert between, which actually is going to let that to be 0 and 1. I'm going to get the current position of the particle. And then I'm also going to bring in a vector 3. So if I create a vector 3, right click it, convert to property. You could also convert it to an exposed property. I'm just going to leave that as, actually, let's call this, actually, let's not do that. Let's go into Blackboard, hit plus, and I'm actually going to get a position, which is just basically a vector 3. I'm going to leave that as new position. Cool. And then I'm going to check the distance between this and say, well, the current particle position, actually. So let's pull this in. Cool. And I actually don't know what this is going to spit this out as, but I'm going to put this into the lerp, and just so we can actually make it nice and visible what is happening, I will set one of them to black and one of them to a nice magenta. Nice and eye-searing. Cool. Okay. This might be the wrong way to do it. We might actually, let me split these around very quickly because I feel like, actually no, that is the right way to do it to make sure everything is in pink. Cool. Plug that into the set color. And what have we got going on? It's hard to tell right now. So we've got this position that we're feeding in and we're checking distance and we're going to use that to blend the colors is the plan. Again, doing nodes live, embarrassing if I haven't planned it. I may be missing something very simple. But if I go in here and I create a cube and we're saying this is potentially maybe where the player is or where anything is right, we want to get the position of that cube. If I go onto the visual effect object in my inspector, and if I go to add component, I can search for the VFX property binder. And then here, if I hit the plus, if I go to transform position, I can then select which one we want. So new position would also accept vector 3. And then I've got the target. So if I drag this cube in, we'll now be taking that cube's position and feeding it in as the vector 3 into the visual effect. So everything is pink. I got that wrong. Let's actually multiply this by, say, 0.1 and see if this does what I want. Actually, let me just very quickly, I'm actually just going to turn off the velocity and see. It might be because I'm leaving it as black here, so let's actually change this to be blue. Hey, there we go. That's working. Yeah, I think it's because it's it can set the color to black when it was already white. Okay, so we should see as this moves around. Yeah, we can actually, so we're setting the color. If I do this in update, we can see that as we move the cube, it will change the particles near it to be blue. Or are we? Maybe we're not. What is going on here? Exposed. I think that might be what I was missing. New position, exposed, compile. Oh, value, world space. Is this going to fix it? No. Embarrassing. Anyway, we can see here that whatever position we're feeding in, we're then changing the particle's color based on that. I think it might be because I'm something to do with set color, maybe it needs to be update color. Don't know. You get the idea, right? Feed data in. Good. Okay. What else is there? Let me quickly go to the blog post. Oh, I'm going to rattle through some of the stuff in there, and then I think we will be done. So let me quickly show this. This is the VFX samples project. If you want to go through some of these use cases and pull apart how they're doing certain things, there is this project up on GitHub, and you can download it and pull through all that stuff. If you want to go and check out more advanced visual effects, there is the Morgana visual effect, which is from The Heretic. So actually, if I put The Heretic visual effect Unity, yeah, here we go, making a VFX-driven character. So this here has been released as a sample. If you remember this from The Heretic, it's a huge visual effect. You can go through and pull that apart. What I actually have in this project here is some of these example projects. So what is currently noise on the screen, let's actually load into the AR radar scene. Let's not save that. Cool. So yeah, this is something made by Vladnikov. And let me just turn off gizmos. Cool. And this here is all running in the visual effect graph as well. So if I actually go onto this here, as I've selected the asset, we can find the asset template. Double click that. We can load up the graph. And we'll see here that this one's using multiple systems to do things like the horizontal lines, vertical lines. There's one system for the smoke. And then there's also things like the little sprite at the bottom. Ooh. Ooh. The computer is not having a good time. Cool, we're in.
Are you sure you have turned off your OBS?
Oh, that's a good point as well. I mean, I don't think it's actually capturing as much, but I've just shut that down. I'm just on a very sad laptop, which has been sitting in my hot flat all day, running Unreal and stuff. Cool, so we can see here, I'm just gonna maximize this one. You can see you can get really wild. I promise I know how to use nodes better than what I currently did. But it's a discovery process as you pull in data, mix match it around. We can see here that they're sampling they have a property for the line segments, and then we're doing a bunch of maths to segment it using modulo to kind of give it its shape. We're using an animation curve to actually curve it out for its position. We have things like over here, the pulse, which is taking in the ID of each particle, and then sampling the time somewhere in there. You can see it gets crazy very fast. But I think there's data being reused between systems here, or not. This all seems to be pretty self-contained. But you could take the same node data and send that out to multiple particle systems, which is really handy. Cool, so let's actually go to explosive visual effects, visual effect graph. So this is the blog post I mentioned at the beginning. So it goes through kind of, again, the basics of installing it, the terminology of blocks and nodes and stuff, things like what the blackboard is and the different properties you can have with it, target game object that we covered, parameter binders that we just covered, links to things like the visual effect toolbox, which is a way for you to bake out point caches. So I'll very quickly demonstrate in a scene. So this is a scene I previously, I think this is, I hope I'm loading into the right scene. Yes, I am, cool. So when I did this kind of very similar demo, which looks somehow better the other day for my colleagues, you can see this here, these little points. This is actually generated from the head of this character here, actually. So I went into Window, Visual Effects, Utilities, and then Point Cache Bake Tool. This allows you to select a mesh and then say how many points you want it to have. And then you can hit Save to Point Cache Bake File. I'm actually not going to hit that in case my computer crashes right now. I don't think it's actually a huge process, but I don't want to lag out either. But it will then take the mesh and kind of bake it into a bunch of points, which can then be read by the visual effect. So that's really handy. And again, if you've kind of made a simulation in Houdini or something, and you want to bake that down into a texture, and you have all the different individual sprites, you want to make them into a flip book where it goes through all of them individually. There's the image sequencer, which will help you kind of do that. Something I didn't cover, I only kind of touched on a little bit, is spawner chaining. So this effect here will start the visual effect, and then after 4 seconds, this little delay here will then spawn this one, which will then stop the visual effect. So this will play it for a few seconds, stop it, and then play it again. GPU events we covered. Timeline, so it's fully compatible with timeline. You can add events and stuff, and then even add data into those events. So here I set up a couple of keyframes that will then change the color of the particle. By adding an event in the visual effect, we can then see that through the timeline track, a property will be changed. And you can also do the kind of usual keyframing of properties. Sample project, we covered that. Cool. I think that's basically, spawner chaining. Where's spawner chaining? Oh, yeah, that's it there. There's another way. You can also have like multiple spawner chaining effects being done, which I have an example of on Twitter. I hope Google is going to pull through for me here. Here we go, yeah. So this visual effect here triggers just by itself that repeating 111. Can I not? There we go, cool. Hey, Twitter video compression, don't we love it? So you can see here that obviously this is horribly unoptimized. We want to do this in a different way, but just to demonstrate spawner chaining, hopefully we get more than 3 pixels in a moment. But by taking that first spawner chaining event, hooking that up to start, and then having that one trigger its own visual effects system, and then that one also trigger another, kind of like dominoes, we could then, you can see here on the left, potentially 1, 2, 3, and then it finally triggers an exposure visual effect. So that's really useful if you want like something to hit, and then after 3 seconds of that, another explosion happens, right? Okay, cool. So I think that's basically it. I'm sorry if that was too much information. I would highly encourage you to kind of go through and just create a basic visual effect. Kind of go in with the, I assume most of you guys have played around with nodes in some capacity before. Go through, see what kind of data you can bring in. You know, you can just search for whatever you like with the create node kind of interface. Let me show that again. I find personally myself, as I was learning the system, to kind of go through with the arrow keys here. So I could like kind of see what exactly I can bring in, kind of discover what's there. You can bring in things like the camera position by default, search for different buffers, those sorts of things. But yeah, thank you for listening, guys. I hope that was really educational. I hope that was a pretty comprehensive overview of how to get started with the system. If you like, maybe we can come back and I can plan something more advanced using nodes and stuff. But yeah, does anyone have any questions?